Okay, so I want to talk about the derivatives of logs. So we have talked about derivatives of trig functions, and we know it's kind of the rules we have to remember. We have talked about derivatives of exponentials. If I say e to the x, what's the derivative of e to the x? So if your equation is e to the x, we know the derivative was e to the x. Remember, if we had a different base, if I said 3 to the x, what was the derivative of that? Yeah, you still have the 3 to the x, but we had to throw in the natural log of the base. And the reason we don't have to have it here is, what's the natural log of e? It cancels. So that's why we prefer the e to the x's, because their derivatives are nicer. Today we're looking at the derivative of the log, and the same is going to be true, that we will prefer when the base is e. Because of this, the derivative turns out a little bit nicer as we go through. So let's first try to figure out the derivative of a log. So if I said log base a of x equals y, we don't have a rule for derivative of a log yet, so we would have to change it to exponential form. What is this in exponential form? A to the y power equals x. But this we can do the derivative of. A is just a number, so the derivative of a number to a power is still that, so we still have a to the y. We would have a natural log of a. And then, because my exponent is y, we have to do chain rule. What's the derivative of y? dy dx. Equals, what's the derivative of x? So my derivative is 1 over a to the y natural log of a. Or we could rewrite this a to the y is equal to what? X. So we could write 1 over x natural log of a. So that is the rule for the derivative of a log. It's 1 over the argument times the natural log of the base. So 1 over argument times natural log of base. And of course, if the argument isn't just a plain x, we would have to do the chain rule as well, derivative of the inside. If we look at the natural log, I think I already gave it to you on the next slide, but let's talk about why. So if we have log base e, okay, we know another notation for that is natural log, right? If we did our derivative using that rule we just came up with, it's 1 over the argument times the natural log of the base. And what's the base of a natural log? E. And the natural log of e is 1. So just like when we're dealing with exponentials, we prefer to have e's. When we're dealing with logs, we prefer to have the natural log, because then the derivative is just 1 over the argument. All right, so let's do some derivatives. Most of my examples are going to involve natural logs, because almost all of our problems will be e's and natural logs. We don't use the other one very often. So the derivative, what's the rule? Over the argument. But we do have to do chain rule here, so times, what's the derivative of the inside? So our derivative is 3x squared over x cubed plus 1. Derivative of the natural log of sine x. So, natural log, that always has to have an argument. My argument is sine. So what's the derivative of a natural log? 1 over the argument. But we have to do chain rule here. So what's the derivative of sine? Or, what is cosine over sine? This seems so nice and pretty after the last section. How would I rewrite this one? The entire thing is under a square root. So it's the natural log of x, all to the 1 half. So the derivative, exponent comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside. What is the derivative of a natural log? And you're welcome to rewrite it if you want. We have a 2, we have an x on the bottom. A negative 1 half just means a square root on the bottom. So you could write it like this if you'd like. So far, so good? Alright, let's do one that's not a natural log, just for practice. So, we know the derivative of a log is 1 over the argument. But because my base is not e, since it's not a natural log, we have to take it times on the bottom the natural log of the base. So we just have to throw in a natural log of 10. Just like when we did the derivative of an exponential, we had times the natural log of the base. We do have to do chain rule here. So derivative of the inside. So derivative of 2 plus sine x. Let's see. This one is asking for the natural log of this whole thing. So, derivative of a natural log is 1 over the argument, which is this thing, times, we have to do chain rule, so derivative of the inside. What would I have to do this derivative? Quotient rule. Low, I'm going to write that as exponent to the 1 half, d high, derivative of the top is 1 minus high d low. So the 1/2 comes down, hand side stays the same, subtract 1 from the power, times derivative of the inside, which is just 1. Over low squared, so if you square a square root, it just cancels. I just have to clean this up a little bit. If you have a fraction divided by a fraction, what do you do? So that would make it the x minus 2 to the 1/2 on top, x plus 1 on the bottom. Lots of ways we could simplify from here. Let's just distribute that to both terms. So the first term, if you add those exponents, you just get x minus 2. Minus, in the second term, positive 1/2 and negative 1/2, they just cancel. What if I told you you can't leave a fraction in a fraction? How could I get rid of that 1/2 easily? Can we take everything times 2? So on top we get 2x minus 4 minus, those would drop, so minus x minus 1. X minus 5 over 2 times x plus 1 times x minus 2. If we simplify it as